Trig-free college sequences. So in this video, we're going to discuss three types of sequences: arithmetic sequences, geometric sequences, and recursive sequences. And we have really a couple of formulas that we're going to need to know, but we'll go through them as we need them. First, the first question: what is the common difference of the arithmetic sequence? Now, an arithmetic sequence gets from one term to the next term through addition and subtraction. Um, what we see here in this sequence of 5, 8, 11, and 14, how am I getting from one term to the next? I'm adding 3. So I get from 5 to 8 by adding 3. I get to 11, 8 to 11 by adding 3. 11 to 14 by adding 3. And it's got to be the same common difference, and that's what your common difference is, and we use the letter D to represent that value. It's basically saying what is the number that I keep adding or subtracting, in this case adding, to get to the next term. And so the common difference here is 3. It's very easy to tell. I mean, you could just look at how do I go from 11 to 14. You can pick any two in the sequence. It doesn't have to be the first and the second because it's a consistent number. But you could just subtract 1 minus the one before it. 11 minus 8 gives you 3. But a lot of times you could kind of just tell. But the more complex ones, you want to subtract any term minus the previous term. And so in this case, the answer is 3. So look at the pattern below. If the pattern continues, what will be the 10th term? First of all, is this arithmetic or geometric or recursive? Now, we haven't discussed the other two. So this is arithmetic. And again, I'm getting to 3 to 10 by adding 7. 10 to 17 by adding 7. 17 to 24 by adding 7. 24 to 31 by adding 7. So this is an arithmetic sequence. And so I could find the 10th term by simply continuing the pattern, which a lot of you will do for these arithmetic ones, and that's okay if you do that, but there is a formula that you really do need to know. And for an arithmetic sequence, it's a to the n, and this is one of those formulas that we're going to practice adding to our reference sheet. It's not on the reference sheet, must be memorized. It's a really important one. So a to the n, meaning the nth term, like our 10th term, goes a1, which stands for the first term in the sequence, plus n minus 1. So if you want your 10th term, that would be 10 minus 1, which is 9, times your common difference d. And so if we fill this in for this problem, a to the 10, our 10th term, so a10 stands for 10th term, equals a1, which is your first term. Your first term here in this case is 3, plus n minus 1. Now, n minus 1 isn't the 10th term minus 1. It's just 10 minus 1. So if I want the 10th term, that would be 10 minus 1 times d, our common difference, which we already established is 7. And so this comes out to be 3 plus 9 times 7. You could do the 10 minus 1, pretty easily, hopefully. And so, you probably don't need a calculator for this, but it's okay if you are. 9 times your 7. Come on. Enter. 3 plus 9 times 7 is 66. And so that is the answer, 66, choice C. Yes, you could have just continued the sequence, and if you do so, hopefully you're getting 66, which also isn't bad, especially with the calculator, just plus 7, plus 7, plus 7. Just don't forget which one you're on, your 10th term, and so on. If this was a part 2 and you were going to do that, just make sure you list all of them out. And I've seen students do that. I've seen, an arithmetic question where they say, what's the, 57th term? And kids will list out all 57 terms. And we'll give you credit as long as it's right, but it's really easy to make a mistake somewhere along the way, just mess up a sign of something or think you're on the 57th when really you're on the 58th. It's easy to lose track. So, but this formula is going to be needed for other types of questions, so it's one of the more important ones that need to be memorized, and we'll add it to our reference sheet. So definitely have that written down. Next, for a geometric sequence, we get to the next term through multiplication. So not addition, but multiplication. And instead of a common difference, we have a common ratio. So how do I go from -2 to +4? Well, I multiply it by -2. And 4 to -8, you multiply it by -2. And -8 to 16 is times -2. And so your common ratio is times -2. And instead of, for the common difference, I said a lot of times you can figure it out, but you can always subtract, some term minus the previous term. That'll get it for you. When it comes to geometric, you could divide. You could take any term like -8 and divide by the term before it, 4, and that'll give you your ratio. So divide any term, which we'll call a to the n, divided by the term before it, a to the n minus 1, right? Because if this is like my 15th term, the n minus 1 would be my 14th term. So my ratio would be any term divided by the term before it. All right, another geometric sequence, but this time we want the 15th term. So again, we can continue the pattern that we're going to see here. We'll talk about that in a minute, but let me give you the formula because you do definitely need the formula. And for geometric, it's very useful. So the formula, again, starts a to the n for whatever term you want. And again, it starts with a1, but instead of plus, it's times your ratio r. And your ratio r has an exponent of n minus 1. So instead of a to the 1 plus n minus 1 times d, it's a to the 1 times r raised to the n minus 1. Again, we're going to practice memorizing that and adding it to our reference sheet on the exam. So our 15th term, that's a15, is my first term, a to the 1, which they tell me over here is -5, negative rad 5, sorry. Negative rad 5, parentheses, your ratio, and n minus 1 would be 14. My 15 minus 1 would be 14. So the hard part of this question, I think, is figuring out what the ratio is. How do I go from negative rad 5 to positive rad 10? Well, it's going to be negative, right? Because I'm going from a negative to a positive. And how do you go from negative rad 5 to positive rad 10? Well, as I said, it is negative, and rad 5 becomes rad 10 by multiplying it by rad 2. So a negative times a negative is positive, and rad 5 times rad 5 is rad 10. And so it would end up, my ratio is negative rad 2. Now again, that may not be as obvious for other people, so what could you do? You could divide. Take any term, like rad 10, and divide it by the term before it, negative rad 5. And you would divide, positive divided by negative is negative, and rad 10 divided by rad 5 is rad 2. And so you could just simply do that. All right, I think a calculator would be very useful here, although we may have to then kind of evaluate these, but let's see. So negative radical 5, and that radical, parentheses, negative radical 2, and that parentheses raised to the 14th. Okay, so negative 286.21, so on, so on, so on. Probably going to be this one, but you could type these in and evaluate them. Let's see, what is the negative 128 rad 5? What's that? And it works out that that does match, so that is definitely my answer. The reason why it is working out to still have a radical in the answer, and again, a calculator way of getting that is fine, but if you just looked at the negative rad 2 part, so let me just do that part, negative radical 2, and just do that to the 14th, that part, that is your 128, and 128 times negative rad 5 times the negative makes it the negative, and just attach the rad 5 on the end. That's why it works out. But just type into your calculator and then evaluate these. That's fine. So that's geometric. We have this important formulas here. Here's your arithmetic to get the next term, or a 15th term, something like that. And then you have your geometric. The last type of sequence I want to talk about is something called recursive. And these really aren't too bad, but they don't follow a pattern of just plus a number times a number. There's almost like an equation to get to the next number. But they'll always tell you what it is, and that's what this weird looking thing is here. Now, a to the 1 equals 1. So they'll typically give you that, and then they'll give you an equation to get to the next term. And this is what confuses students the most. This a to the n minus 1 simply means term before a to the n. So I have my first term is 1. But if I want my second term, it's 3 times a to the n minus 1. A to the n minus 1 simply means previous term. So for my second term, it's going to be 3 times my first term, which is 1 minus 1. 3 times 1 is 3 minus 1 is 2. And then for my third term, a to the third, would be 3 times my previous term is my second term, so that would be 2 minus 1. And that would be 6 minus 1 is 5. And then lastly, my fourth term, which is actually what I want here when it says find A4. My fourth term is 3 times my previous term, 5 minus 1. It is 15 minus 1 is 14. And that's my answer. So recursive isn't too bad. It's just instead of plus or minus or times a specific number, it's a formula to get there. But they'll tell you what that formula is. Just remember that the a to the n minus 1 just means the term before it.